Get started. Hello, my name is Nathan Clouse. Today I'll be talking about developing for F&O using Git. Um, I'm a Microsoft MVP. I'm also a technical architect with Vista Corporation here in the U.S. Um, there's all my contact info. I have a blog at atomicax.com. Myself and a few of the other MVPs here in the U.S. put together dynamics.fo, which has an inventory of data entities and features that were released by version dating back almost a year. So some good stuff there. If you're on the latest and greatest version, then you want to know what's been released or what's coming out for the next version for you. That's my LinkedIn. My Twitter username. If you want to get a hold of me, I'm also on LinkedIn. I'm pretty easy to find if there's any questions. So today we'll be talking about how to use Git for source control. We're going to talk through some of the things that are going to be a little bit different as compared to TFVC. Just how things would be different, what other options there are out there. And I'd say most importantly, I'm going to have a demo. So in the past, I've talked about it from more of a theoretical standpoint, but now I've gotten everything figured out to the point where I can actually show it to you, and you can implement this tomorrow, maybe Monday if you'd like. Lastly, we'll talk about branching. Branching is a very complex subject, so we won't be able to spend a lot of time on it, but it's worth mentioning. One of the things we need to talk about first is package management. So when you're using TFVC, you put basically your entire local packages directory under source control. But with Git, we can't really easily do that. So you have sort of two paths ahead of you. You can do one package, which would contain all of your customizations. This would just be a folder inside your package's local directory that is version controlled, and everything else just sort of gets ignored. It's easy to set up. It's easy to use. So I do some various things on GitHub. That's what I use there. I have a project that equates to one package that does one thing. And if you want that, you just can copy the source code locally, add it to your environment, and go on from there. But this using one package is very rigid. You're only ever going to have that one package. You can have as many models as you want, but you're stuck with that one package if you go down this road. You could potentially do multiple repos, but then you have one repo per package, which means you're connecting to potentially different things all at once, and you've got to manage your dependencies if there are any. So it can be a hassle. But the other path you have available is doing multiple packages. So this is very similar to TFVC, where you put your package's local directory under source control, and then you can have as many packages and as many models in those packages as you want. You can even include source packages, like if you have a compiled package from an ISV, as well as source packages. And you can do it all in one repo. So if you have one person that's installing an ISV, they can do that in one branch, and someone else could be doing customizations in another branch, and they will all just sort of magically merge together at the end. When you're looking at the life cycle of a branch and how things are different compared to TFVC, I got on the screen here sort of the left-hand and right-hand side of what the different roles related to a customization would be. On the left-hand side, we have a tech lead, and they may create a work item or review a work item to confirm that the bug does exist, or this is a feature that we do want to pursue, or verify whatever that means for your organization and your stage of your implementation or post-go live support. Once it's verified, the tech lead will get it on the schedule, and as soon as we get it, we're ready to assign it to a developer. We're going to create a branch for that. And if you're unfamiliar with branching, just say this is a work area for where this work is going to take place. Now, once we've got our branch, we're going to go ahead and just assign that to our developer. Then on the sort of the developer side, what they have to do is get their work, do the work, commit the work, and then create what's called a PR or pull request. We'll talk about these in greater detail, but at the beginning of the process, you get an email from, let's say, DevOps to say you've got a ticket assigned to you. You run through this normal life cycle like you would with any customization, and then at the end you create the PR, which is just you raising your hand and saying, I'm done with this. I need someone to review it. And then lastly, from that pull request, it goes back over to your tech lead or another senior developer to review your code and accept the pull request and get it integrated back in with where everything else is. This is an example of what branching would look like inside Git. This doesn't necessarily have to make a lot of sense right now, but what I want to call out is, we've got all of our features along the bottom. And when we take those features and roll them up to develop, the next step is when we take develop up to version 1, we're taking everything that's been merged into develop at that time. So in TFVC, we've got change sets. In Git, we've got branches, and we bring those branches up with everything in them, regardless of change sets or commit numbers or anything like that. So that's just a call out that you sort of have to plan ahead and think about when stuff gets merged, how you merge it, and the timing of that. During our demo today, we're actually going to talk about how to do something very similar to this. So you'll get to see sort of what some of that looks like. When you're a developer working inside Visual Studio 2017 or 2019, I'm going to be using 2019 today. 2017 is a little bit different, but the core concepts apply. You'll get your work. You'll convert over to the branch for that work item. Do your work, test your work, hopefully. And one of the callouts here that I want to really highlight is that you can commit your work at any time. Because we are not taking change sets by change set number, and we're taking entire branches at the end of the development lifecycle, you can commit at the end of the day. You can commit every 2 hours if you want. You can commit however it makes most sense for you. And that doesn't make extra work down the line for, now I have to, find these 18 change sets related to this ticket number and individually merge them up one by one. So if you are working on one, let's say you're working on feature A, and then someone says, hey, we've got a bug. I really need you to look at this. You commit for feature A, you flip over to the branch for bug B, get that addressed, commit there, then flip back to feature A. So it's very fluid, and you can sort of jump around and hop around. And that's not something we really have in TFVC. When you commit with Git, there's automatic continuous integration feedback. So you commit, it'll do a build, and you can configure what that build does. So just as a compile or compile with best practice check, you can just get that feedback from any kind of commit that you do, just so you know if you committed something broken, or you would just want to see what your best practices are from a list. Really just whenever and whatever works best for you. Based on that feedback, we can retest or redo our work. And I want to call out here for that continuous integration feedback. Depending on your branch, you can include ATL testing and RSAT testing if you want. I will talk about that a little bit later. But then finally, once you've got done your work and integrated any and all feedback you've gotten from automated systems, you go ahead and create your PR or pull request, which just says, hey, I'm done. Someone needs to review my work, and you're going to move on to the next thing. And to really draw out that you can flip between different development efforts, I want to call out this right here. So we've got one developer along the bottom who is working on 2 different features at the same time. And you'll notice in order to do that on one dev machine, they're going to have to commit and flip between the 2, which is perfectly everyday and normal for people who are familiar with Git. If you've only ever used TFVC, that is sort of mind-blowing. But it's just one of the great flexibility options that comes with using Git. The next question that you're probably asking is, well, can I use GitHub? So GitHub, is a competitor to Azure DevOps. So yes, you can use GitHub if you'd like. Should you? There's a lot of potential drawbacks. It's entirely not supported for use in an implementation project. There's no real documentation from Microsoft, and the documentation from the community, I'll say it's good. It's not great. It's not enterprise grade by any means. So it's sort of just a risk related to that. Again, similarly, the build and release stories are not really complete. When you look at the tools and tooling that we have available inside DevOps, those are pretty good. There's some things we'd like to change, but overall, we can orchestrate and just get our packages and our code moved around with some automation and approval and workflow. In GitHub, they have competing products and services that do similar things, but it's not a one-to-one match. So there may be some shortfalls there in terms of automation or functionality, or just straight up some stuff may not work. You may not have some tooling available because it doesn't play nice with the way that GitHub does builds as opposed to the way that DevOps does builds. So again, a lot of unknowns. And here's where if we have any staunch advocates around GitHub or DevOps, this gets controversial, is that Azure DevOps is for enterprise, and GitHub is largely for community. If you're a company on GitHub doing non-open source things, sort of good for you. You get free karma points, but that doesn't necessarily mean GitHub is enterprise grade yet. They're playing catch up. GitHub is becoming a contender to DevOps, but in terms of if you need a tier 1 platform for DevOps, along with some management capabilities, in the Microsoft space, there's one product, and it's DevOps. Next, I want to talk about what a pull request is. So a pull request is, just you indicating that you're ready to begin the process of merging new code into the parent project repository for that code. And it's the developer that creates them. No one is going to really create them for you. That's, as a developer, the developer is saying, I'm done with my work. I need it to be reviewed. And unless if you don't do that pull request, people assume that it's not done and you're just going to continue to work on it. Once you make that pull request, depending on your organization and staffing levels and a lot of different variables, it'll go to someone to review it. So in there, they can see what changes were made with a diff. They can see how stuff was automatically merged. They can just review all of your work and say, yeah, this is good, or no, I reject this for these reasons. Any of those reasons, could be from the last session that we just heard. But once, someone reviews it, it goes over to someone else to potentially approve it, or there may be automatic approvals in place. But there is a review process, and it's built into the process, and you would have to potentially, on purpose, short circuit that to get rid of it. When we look at what merges them, it's actually DevOps that's doing the merging for you. Because branches don't live as long, and you're making a workspace to add some new code, and let's say you plan on merging that up at the end of the week, the amount of time that code has to get stale relative to the main thing that's based on is much smaller. So if you've had issues with TFVC in the past where a developer just starts developing and they did not do a get latest before they started making a bunch of changes, you've got a merge nightmare because you have to figure out what they added versus what was there when they added stuff, because they actually added stuff 6 months ago because they didn't do a get latest. That sort of thing goes away. And when we sort of dive into this, this would be our reviewer. They would take a look at everything, do whatever the review process is. It could be review best practice logs, so you can get those with some build automation. The customization analysis report, if you like the output of that. Additionally, you could include RSAT and ETL tests in here for them to review. So the reviewer could just say, yeah, no major BP issues. The CA report's fine. RSAT and ATL passed, so looks good. They just sort of rubber stamp it. Alternatively, if we started failing some tests, you'd get some feedback as a developer to say, hey, go address these issues based on these tests. Then from there, get reviewed again, because that would be a new pull request. And then eventually, once reviewed and that review is marked as complete, it would go to an approver. which will potentially be someone else, just to make sure that you've got one developer, one reviewer, and one approver. Um, so there's no malicious code or anything like that, or even just major flaws in a design that make it back up into the parent branch. Um, so one of the things that this new sort of review process gets us is, we don't have stale code, and there's a lot of nice things that can happen, but it's not going to prevent code reviews that go like this. So there's, if there's bad code out there, there's still going to be out there, and there still might be some weirdness based on requirements or whatever the case may be. Next, I want to talk about YAML. So in the lore of the internet, YAML was sort of a tongue-in-cheek acronym for yet another markup language, because it was made around the time when a bunch of other markup languages were being made. And they've since changed the name to, or the acronym to mean YAML ain't markup language, so it's its own recursive acronym. But what YAML is just a human-readable data serialization language. It's commonly used for config files or instruction files, stuff like that. And that's what we'll be using to build our pipelines. So if you're familiar with the TFVC, I think it's called a classic pipeline editor. This is very similar to that, but this is all text-driven. And what can you do with it? Well, you can store config data or config with instruction data, like we are going to be doing with our build pipelines. And examples of what you can do with this are, do a build whenever there's a commit, a build on a pull request, a build with testing on a pull request, and also just schedule these things to happen, let's say, every night or every Friday night or whatever the case may be. So just key differences that I wanted to call out. When talking about TFVC versus Git, people say, TFVC, well, it's supported by Microsoft. Well, technically, yes, Microsoft does support the use of TFVC with F&O, but that's confined to just, does TFVC work in terms of it has no bugs and has no security issues? They don't specifically support your implementation of TFVC with F&O. So there's a lot of qualifiers there. So it's not really supported in the way that it is when you say, well, it's supported. Well, there's quite a few qualifiers. TFVC is, again, push-based, and our branches last nearly forever. So when you're looking at implementation versus post-go live, you may have fewer branches post-go live, but your dev, test, release branches are pretty much always going to be there. And because of that, I call it monolithic, which just means at the beginning of your project, you set everything up, and then it never changes. When looking at Git, it's not officially supported by Microsoft in their support channel. Outside of, it's a thing that works. They support the product itself, like they will support F&O, they will support Git, but not necessarily offer any support if you run into issues with using the two of them together. But if you run into a Git issue, which is just solely related to Git, that's something they do support because it's their, it's just a product they support. Next, Git is more modern, so I'm not sure about everyone else here, but priorities may flip from day to day, and because of that, I can commit at any time and flip over to work on something else. And one of the key things that makes that work is it's pull based, so we're pulling entire branches up rather than worrying about change sets. And again, branches are short-lived inside Git, so if you have a customization for a report, I'm going to make a work area, a branch for you to work on that. You're going to do your work. You're going to, signal that you're done with your work. I'm going to accept it, and that branch goes away. And that's just part of the life cycle. And lastly, if you've only ever used TFVC, this is going to take a fairly significant change in thinking, just because it is a very different control system. And you will at least in the beginning, be out of your comfort zone if that's all you've ever used. But enough sort of about the theoretical. Let's dive into a demo. So I'm going to stop sharing and then share my desktop. So one moment, please. Let's remove that over here, bring this up. Okay, can everyone see my screen? So let's see here. Guess thumbs up if you can see my screen. So you should see Visual Studio. Okay, so I got a thumbs up. So I'm going to bring up some notes real quick just to speed up the process. So what we're going to do is very quickly, I'm going to go into DevOps and we're going to set up a whole new project. So we're going to call this a new project. We'll just call it Power Summit. It's going to be marked as private. We are going to use Git. Work item process doesn't matter for my demo. So we'll wait for that to be created. Okay, so now I've got a project. We're going to go ahead in here and initialize our main branch. We are going to add a README. We are not going to add a .git ignore file. We'll cover that in just a little bit. So click initialize. So there we go. We've got our repo with our first branch. So now we can go into Visual Studio. A lot of this I've pre-staged, so it may not be this smooth your first time around. But I'm going to go to Team Explorer, click Connect, Manage Connections, Connect to a project. Let this populate. So here we go. Here's Power Summit. I'm going to go ahead and click Connect. So now I've connected to the repo. So let's go look at Git repository. So we actually want to clone it. This looks a little different than I was expecting. So just one moment, please. Okay, well, we'll do it this way. So first thing that you're going to notice is I'm going to do things a little bit out of the ordinary. I don't need that there. So I'm going to map this and clone this to C/source. You can specify whatever file path you'd like. But I'm going to clone to this. So clone from DevOps to here, and it's going to show up in source/Power Summit. I'm going to go ahead and click clone. So I'll give that a moment to clone. Okay, so now we've got everything here. If we had any code in here, we'd want this to be exposed to F&O. So here, there's a trick I wanted to show everyone that is not supported by Microsoft, not condoned by Microsoft. It may be a bug. It may not be there the next time you use this. So there's a lot of qualifiers there, but it seems to work currently. So I'm going to continue to use it. If you open up your web.config file, there is a specific key we're going to change. So aos.metadata directory. And we're going to change that to where we cloned our repo, which is going to be C/source/Power Summit. And I've done this a few times before just to make sure the process works. So now when Visual Studio looks for custom packages, that's where it's going to search. I'm going to close Visual Studio because it does instance that file when it opens Visual Studio. So I'll go back in here. Going to continue without code, and then we're going to take a look at our changes that have happened to our repo. So So why is it telling me that I need to clone my repo? It's going a little bit differently than the last time I did it, but I think I can correct it. So we're just going to go ahead and create a package and just sort of see what happens. So, go to model management, create model. And then I guess wait for Visual Studio. So I'm going to call this one test 111. Publisher is me. Again, these values don't really matter. I want to create a new package. Don't really care about my references. I don't want to create a new project, but I do want this to be my default for new projects. So I'm going to open the folder for this. Select folder. There we go. That's what I was expecting to see. So now when you look at our change log, so this is where you would see your pending change sets. You can see we've got some stuff that was added from Visual Studio, as well as our descriptor file that we just created. And that's in /source/Power Summit, not our packages local directory folder. So far, so good. You saw that Visual Studio was able to put a custom package somewhere else other than package local directory, which is what we wanted. But now there's a lot of stuff in here that I don't need, like this .vs folder. It's just Visual Studio settings that would be unnecessary to get included in there. So what we're going to do is go to our Power Summit directory. You'll notice we don't have a .gitignore file, so we're going to fix that. So we're going to go to Team Explorer, click on the doobly-doo, go to Settings, go to Repository Settings. There's my email if you want to get a hold of me. And then we're going to add a gitignore file. Go ahead and click OK. Go over here to Solution Explorer. So one of the other key benefits of Git is this gitignore file. So when you place a directory under source control with Git, it's going to version control every file and every directory underneath the parent directory. We don't really want it to do that because it's going to include stuff like XPP metadata or bin, a bunch of other stuff. So I'm going to just copy and paste in some values and we'll explain what those are. So the first instruction in our gitignore is to say just ignore everything in this directory, which is going to be Power Summit. Next, we want to keep our test 111 package folder that we just created, but we want to get rid of bin and resources and XPP metadata and a few other things from that, because those would be generated on a build and we don't care about that stuff. Next, you can see I've got a thing here. We want to keep our projects folder. So let's go ahead and make a projects folder here. This is what would hold all your Visual Studio projects. So now that we've got a project folder, let's go ahead and make a new project. So I'm going to close folder. Yes, save that. Create a new project. So we'll do finance and operations. Project name is unimportant, but we want it to go to our Power Summit directory in Visuals or VS projects. So click select folder. Name doesn't really matter. I'm just going to go ahead and create this. So there we go. We've got a project. Let's just confirm where it put it. So yep, there's finance operations 1 folder with our solution. Everything looks good. Now if we go over here to Git changes, you can see our changes from our gitignore file were applied. Now we're only paying attention to stuff that is our descriptor file, our project file, our solution file, and also the .getignore file, since that's under source control as well. So I'm going to go ahead and add those to all my staged changes. And then in here, I'm going to add something. First, let's go to options. Want to validate that. Okay, organized by element type is set to yes. So okay. So I'm just going to add a class. It doesn't really matter what I add because really this code isn't going anywhere. So go ahead, hit save. So now if I go back over here and see, now I've got class 1 that I just created in my pending changes. I'm going to go ahead and stage that. And yep, I need to save my solution as well. So save that too. So again, stage all those changes. So now what I've done is add a package, add a class, add a solution and a class to that solution, as well as make a few changes to my getignore file. So if you've followed along so far, one of the questions you might ask is, well, what happens when we do a build? Because I've got code in one place and my package's local directory somewhere else. Well, let me show you. So we're going to build this model. It has one class, so we'll get at least one XPP data entry in our folder. So I'm going to go ahead and close that. So when we look at our Power Summit folder, we can see here's test 1 package. We've got an XPP metadata folder in here with presumably stuff in it. But then if we flip over to our packages local directory, I want to call this out. Here's test 1 with just our compiled code. So we can have source over here under source control, and the output of that gets copied over into packages local directory, and that's how the AOS can see it. Again, not supported by Microsoft, and it may be removed in future patches, but for sake of a demo, this made it really quick to make it work. So I'm going to go ahead and say initial commit because I'm adding my, just some basic resources. I'll go ahead and hit commit staged. One of the things that's different about Git is you can work offline and then sync up later. It doesn't really make sense because I'm on a cloud VM. Obviously, I have connectivity to the internet. But if you're ever working on something locally, like on your laptop with another language, you can commit. Well, you can commit stuff while you're, let's say, on a plane and don't have internet, and then sync up later. But I want to go ahead and sync this up with Azure DevOps right now. So I'm going to go ahead and hit push. So successfully pushed. So that means it's now actually on the server in DevOps. So if I go over here to commits, we should see first commit where I actually made the repo, and the second commit where I just added the stuff in Visual Studio. So next, what we want to do is, so we've got a package, we've got a model, we've got source code, it's all committed. The next thing we want to do is, these are pre-staged. So here are my config files related to doing a Azure hosted build. I just pre-staged all that along with my artifacts based on Adria Erste's, I guess, series of blog articles on this. And if you haven't read those, go read them. And then lastly, I've pre-created my Azure Pipelines YAML based on the YAML file that yours Degrada published a year or two ago. So these are all just resources that are openly available on the internet. I'm just copy pasting them in here to speed things up. But so I've got my build pipeline here, and I've got all of my assets related to executing on that pipeline. So what's the one thing that I should add? I'll go ahead and close this solution. We're going to make a new solution. Um, so what do we need in order to actually execute our builds? So, and I've got chat over here, so I can hopefully see an answer. We need a build solution. So we're going to go ahead and create one of those. So click create. I'm just going to call it build. Everything is built pre-staged against that. It goes to our default package. I'm sorry, default model, which is also the same name as our package. So I can go ahead and click save, and I can close that solution as well. So I'm going to just close out of that. So now if I look at my Git changes, so here's my pipeline. As code, here are my config files for an automated build, and here's my build project. So, so add build artifacts, and go ahead and commit those. And then push those up to Azure DevOps. So Ivan, I'll just answer your question real quick. I'd say there's no on average. It's really just I'd give it a try. And when things go great, things go really great. When things go a little bit to one side, that's when you start learning a lot really fast. Git does not like it when two people are making changes in the same place. That's why we use branches a lot. So, Ivan, you may have a branch for you for one change set, and no one else should be in there working on stuff because that can screw up your stuff because they get out of sync. So it's really branches are meant for one person to be working in. But I mean, you can go ahead and try it, and ping me with any questions you may have. So next, we're going to hop over to DevOps. So we're going to go ahead and create our first pipeline. So I'm going to click Create Pipeline. Now this is going to be subtle, so I want everyone to watch closely. I'm going to go to an Azure repo with Git, click on Power Summit. Let me double check some stuff. So I did see that. Let's double check and make sure that actually went up there because I don't see some artifacts I would expect to see. Successfully synchronized. So let's refresh this. Oh, okay. I know what I did wrong. I put these in the wrong directory. They need to go up one level to our root directory on Power Summit. So that was just typo. So there, fixed build artifacts. I'm going to go ahead and commit that. Sync that. So you can just see right there, I made a mistake. I've identified what it was, fixed it pretty easily. Now everything is synced back up. So I'm going to go back in here and create my pipeline again. So create pipeline, this, select my repo. It detected that I had a file called Azure-pipelines in there. This is, again, just straight from Microsoft. I'm going to go ahead and click Save. So now that's it. I've got my pipeline. So next, what we want to do is that main is pretty well set up at this point. So one of the things we want to do is hop over to branches, and we'll start putting some policies on our main branch because we really don't want to ever commit to it directly. So the first thing we're going to put is, check for link work items. What this is doing actually two things in one. When I click this, it says I can no longer commit to this branch without an associated work item. Also, commits cannot be associated to work items, only pull requests can. So I've effectively made it so I cannot commit directly to main. The next thing I want to put in is this build validation. So validate code by pre-merging and building pull request changes. So I'll go ahead and click that. I'm going to say, here's my pipeline. I'll just take the defaults for now. So now when I do a pull request, it's going to execute my default pipeline based on the branch that the pull request is coming from, which was that file, which was azure-pipelines.yaml. So now main is pretty well set up. Let's actually start doing some work. So we're going to go over here. I'm going to create a new task. I'm not sure, fix the thing. So there, I've got a task assigned to me to fix something. From here, let's say, pretend I'm the dev lead. I can say, oh, yep, that does need to be fixed, whatever that is. And I'm going to say, all right, this is a bug. I'm going to assign it to someone. And right before I'm ready to assign it to someone, I'm going to say new branch. And I'm going to give it a branch name. So this is task 15. So I'm going to give work item 15, branch name, task 15. And it's based on the Power Summit repo on the main branch associated with this work item 15. So go ahead and click create branch. So now let's see if our build automation kicked off. It did. So here's what just happened. I made a new branch for a developer to use. What this is doing is validating the branch I just made compiles, which seems like a pretty basic thing, right? But I'm confirming that the code that my developer is starting with actually does compile. So if he comes back with code, he or she comes back with code that does not compile, I can say, it worked when you started, so it's not working now. We need to address that. I'm going to go ahead and cancel this build because I don't really want it to run. I'm going to start stacking up builds here. So now I've got a work item assigned to me. So let's hop over to Visual Studio. So I'm going to go ahead and click sync. I want to make sure I have my local repo and settings and everything is synced up with DevOps. I'm going to go to Team Explorer. I'm just going to click on this. So now let's go for the Power Summit connection. I'm going to click on Git repository. And I should now have a branch under remotes called task 15. That corresponds with work item 15, which I just created and assigned to myself. Double click, some magic happens. I'm now in that branch. So when I go over here to Solution Explorer, actually, what's a better way to see it? If we go to Git changes, you can see I have no changes and I'm working against branch task 15. So I'm no longer working against main. I've totally flipped branches. So now let's go ahead and open our project from before. So I'm not sure how to fix the thing, but we'll just add another class. So there we go, class 2. Go ahead, hit save. Hopefully that fixed it. I don't know what I was fixing, but now you can see we've got our new class 2, and we also added a new class definition to our project. So there's our project change. So here I'm going to write fixed the thing, and I'm committing against branch task 15. I'm going to go ahead and hit commit all, and it's committed locally. So I'm going to go ahead and push this. So now it's successfully pushed that up to branch task 15. So if we bring up DevOps real quick, we can take a look at this. So we should have a link to branch task 15. Let's take a look at that. So there's class 2 in branch task 15. So everything's good. So now I think I'm done with my work, right? Because I think I fixed the thing. So the next thing we want to do is go to our repository for our branch. Create pull request is not showing up like it did the last time I did this. So something's a little bit different. Okay, well, doesn't matter. Visual Studio isn't playing nice. So what I can do is go over here to my branches. So here's task 15. So I just updated task 15, create a pull request. So I click on that. So what this is doing is saying merge or create a pull request to merge branch task 15 into main with these and such files, class 2 plus our change to our solution, that one commit um, with some titles and description as to what exactly is going on. Associated with this work item of task 15, and I'm going to go ahead and click create. So here's our pull request, and I just want to call this out real quick. So our first policy passed. So we are, we did create a pull request associated with a work item. So we can't just have pull requests coming out of nowhere. Additionally, this required check of doing a build is now queued. So I'm going to go over here to my pipelines. This one is executing. I want to cancel that one because I don't need that to run, but I did want to call out something that happened here. So our first individual CI is from when we created the branch to confirm our branch compiles before anyone starts work. The next one was I added a commit that's where I said I fixed the thing. That was me adding class 2. Here's what that would look like. So I did a commit and it's already kicking off a build, and it would send that feedback back to me if it didn't compile or however that build is configured to run. Next, here is our automated PR build or pull request build based on I've signaled I'm done with my work, and I want it to go to its next stage. And here we are. So what this did is it took all of our changes, merged them based on the default merge type for that branch, which is always going to be, I think it's fast forward. That's what you'll most often use. Merge those in, so we have this working branch that's equal parts task 15 and main. We're building that, and then we're going to get the build results of that branch on our pull request. So before it even goes to a person to review, it can pass a does it compile test. Does it compile and database sync, for instance? Does it compile, do a database sync, pass all my RSAT tests and all my ATL tests? You can build that in as well. Before it even goes to a person. So if it fails any of those, you can just say, pull request denied based on these failed tests or this feedback. Go address these and try again. So while waiting for this build to run, were there any questions? So no questions? Everyone understood that completely? So it takes about 3 minutes for these builds to run. So if we don't have any questions, we're just going to sit here in awkward silence for a minute. Okay, we're starting to get some questions. So using Git, how do you manage the dependency factor for XPP objects? So one of the things that you can do is, you can't have tables without extended data types, and you can't have forms without tables. When you're looking at scheduling your builds, you can just say, based on this technical design documents, go create my extended data types and tables as one branch. That may take a few days. You get that branch back, and okay, great. I've got my underlying objects that I can move to the next phase, which is build my forms or build my classes. So you can decompose your problems into much smaller things that you couldn't do in TFVC. TFVC was just, here's 240 hours of development. Let me know when you're done. In Git, you can break that down into smaller chunks. And then next question was if you would have to mention one single big reason to adapt to Git, what would it be? I guess for me, I flip between different things on a near daily basis where sometimes hourly basis. It really depends. So I may be, trying to fix a bug where I've got some performance issue related to some integration, and I, need to connect to that branch, fix one thing, like, add an index, something really basic, commit it, and move on to my next thing. So it's just much more flexible. I don't want to use the word agile because that means different things, but it's just more fluid as to what your priorities are. They may change. If you do waterfall, TFVC is great for waterfall, but most of us don't do waterfall. So I had another question: is this all using Cloud Host Build Agent? Yep, this is all executing in Azure right now. So this isn't a build machine. This is actually running against my Gmail account, which I have MSDN Action Pack against. So yeah, no special or additional cost here. It just sort of automatically works. So hopefully there will be a recording. So someone is asking about that. So I guess there was a question, will we need multiple build agents? Potentially, depending on how many developers you have. You get one build slot or one build execution slot at a time. So you noticed I was manually canceling builds because they were going to start to stack up because I had that one slot. They take this one took 4 minutes to run. So if there's a lot of developers doing a lot of commits, potentially. That being said, if you can wait an hour or two in the middle of the day for you to get feedback, that's fine if you can be a little bit patient. There's also a cap on the number of free hours you get from Microsoft, so you may want to look at that as well, or at least monitor that. But in general, I think you get 3,600 minutes for free. Don't quote me on that exactly. So again, really just watch your build times. Do I have any issues with label files, or do they merge fine? Yeah, 98%, yes, it's fine. Really, when you get issues is when you start trying to bring in stuff from stale branches. There's actually an area in here when you can look at your stale branches, and these are just, they call it the danger zone if you're on GitHub. So yeah, just be mindful and make sure your branches are short-lived and you won't have hardly any merge issues. And when you do have merge issues, you can just go in here to your pull requests. It show up in here. You can pull those down to Visual Studio, do your merges manually there, commit those, so that'll go back up to the pull request, and then you can kick off a new build and see if that addressed it. Are there any tools to synchronize or migrate from TFVS to Git? I actually wrote an article on my blog. It'll be listed at the very end that walks through how to do that. You can do it in about 5 minutes if you're really comfortable. The first time, probably 30 to 60 minutes. But there's no specific tooling around that, but there's a defined process that we can run through to move from one to the other if you'd like. Next question was, how do you manage releases to UAT, test UAT in production? So very similar to how you would today. So I don't have an environment to automatically deploy this to. Why does it say failed? Uh-oh. Oh, that was my CI build, not my pull request build. Scared for a second. So very similar to how you would do that today. So if we go to our pipelines, although this is a cloud hosted one, if I look at what was published, here's my drop. If I add in all the other tooling related to having this go to LCS or automatically deploy, I can add that in here too. I just don't have an environment to send it to right now. What about database synchronization? Again, same as today. If I want to send this over to a hosted build box where I actually have a database connection, I can include that in my job. In my pipeline, and it'll do that. So if I have any issues with people renaming or changing data types or whatever the case may be, those would be called out. But that would be outside of the cloud hosted build But again, it worked just like it would today with TFVC. Okay. So I've got 4 minutes left. So the last thing I want to call out is, so here's our pull request. You can see our 2 required checks passed. I'm going to do a fake review of this. Yeah, it looks good. So, I'm reviewing and approving my own work, but now I'm going to go ahead and click approve. So this has been approved. So now the next person in the review process can go ahead and click complete. So from here, I'm going to do a merge type with a, I'm going to complete the associated work items related to this, and then delete branch task 15 after I'm done. So go ahead and hit complete merge. So this is going to spin for a little bit. So let's take a look at our work item. So you can see our now work item is done. It said, completing pull request 22 and the associated work items. If we look at our history here, you can see we added a link to a branch. We added a pull request, the commit for that pull request. We updated our ticket to be closed and deleted the link to our branch because it's gone. And now everything is on that pull request. So we have traceability as to where everything went, but the source branch is gone. Then if we go over to our files, so you'll see, just want to call this out, task 15, that branch is gone. We're now back to main. If I look at main, let's look at, we should have 2 classes in here now. So now main has 2 classes. So everyone and everything is happy. Yeah, and that's pretty much it. So I'm going to stop presenting here, then share this screen. So yeah, just high level, that's the process that we went through today. When talking about branching, there's a million different ways you can do it. Here's an example of one. Here's an example of another. You just have to figure out what works best for you and how you want to manage stuff. So I'm right at time, so let me know if there are any questions in the chat. A lot of the stuff that you saw today, I also wrote articles on. Specifically, everything today is going to be at this link here. Again, here's all my contact info if you'd like to get a hold of me. And other than that, I'm trying to get over to chat. Thanks for spending part of your Saturday with me. Let me know if you have any questions, concerns. If there's anything else you'd like me to write or present on, just let me know. Actually, right before this, someone asked me to do a deeper dive on automatic merging. So I'll be writing on that too. So thank you again.
Thank you, Nathan. I think there's a question in the chat by Paul. But yes, thank you so much, Nathan, for joining us all the way from the US today. Great introduction to Git and obviously, especially when it comes to F&O developers. I think is an important practice that a lot of the Dynamics community, the CE community obviously picked that up a few years ago. It's gained a lot more maturity, but for F&O, it's obviously something that's newer for the F&O community. And thank you so much for helping the community to begin those implementation practices for Git across development. Okay, well, anyway, we're on the hour. Perfect timing because